So this is the question number 52 which came in GATE 2016 and set 1. The question says the second and the fourth day BOD value of seaway samples are 100 milligram per liter and 155 milligram per liter. The value of BOD rate constant expressed in per day is okay. So BOD, so we know that the BOD at time t is equals to LT is equals to ultimate BOD 1 minus e raised to power KT. Okay, so using this formula we can write, so second day BOD will come out to be 100 is equals to L naught 1 minus E 2K. Okay, however for fourth day BOD it will come out to be 155 is equals to L naught 1 minus e raised to power minus 4K. Okay, so now we have two equations, equation that is 1 and equation 2. So using both equation 1 and 2 we have to get the value of BOD rate constant, that is the K. So the best way to solve it is first you take the equation, so if you in ratio form, so 100 divided by 155. So if you, so 1 by 1 is to 1 divided by 2 is equals to L naught will get cancelled. The numerator will be 1 2K divided by 1 minus e raised to power minus 4K. In this way we eliminated the ultimate BOD L naught. So now if to proceed further, so let's assume, let e raised to power minus 2K is equals to T. Okay, so if so then, so then it will come out to be, so if e raised to power minus 2K considered to be T, so then we can write it as 100 divided by 155 is equals to 1 minus T divided by 1 minus T square. Okay, so if you write like this and 100 divided by 155, okay, so if you do, so 1 minus T square is equals to 155 by 100 1 minus T. Okay, if you solve this you will get a quadratic equation which will be T square minus 1.55 T plus 0.55. Okay, T equals to 0. So if you further solve it, it will be uh, 1.55 minus 1.55 T. So now if you solve this you will come to this. So now this has become the quadratic equation. So when you solve this quadratic equation, there will be two roots. Okay, so after solving this quadratic equation you will get two roots. So t is equals to 1 and another you will get that t is equals to 0.55. So t cannot be, we cannot take t is equals to 1 because we have assumed e minus 2k is equals to t. If we take t is equals to 1, so basically ln, so minus 2k, so ln 1 is not possible, ln 1 is equal to 0, that is not possible. Okay, so what we have to do, we have to take t is equal to 0.55. So if you take t is equal to 0.55, it will be e raised to a minus 2k is equal to 0.55. So the 2k comes out to be ln 0.55, which comes out to be k is equal to 0.299. So okay, the k value comes out to be 0.299. So one catch here is, if t is equal to 1, if you take, so see, if you take t is equal to 1 minus 2k is equal to ln1 is equal to 0. So k cannot be 0, the rate constant cannot be 0. Okay, in this question. So based on this we will take the value t is equal to 0.55. We will substitute with the value of t which we have considered previously, and then from that we will calculate the BOD rate constant. 0.299 is the BOD rate constant. Okay, so it is 0.299 per day. So again I will explain. They have given the value of BOD at time t. So we first took the ratio to eliminate the another variable, that is L naught, because that is not mentioned in the question. So now we are left with only one variable, that is k. So we considered e raised to minus 2k as t, so that we can easily solve this equation, else it will become a difficult. So considering t, so we got one quadratic equation. Then the quadratic equation will have two roots, so we considered the 0.55, and t is not possible, so using that we got the value of k as 0.299 per day. Okay, thank you.